This is Mr. Martin. This is Geometry Honors video notes for section 8.1. We're going to be talking about ratio and proportion. So we've got a number of different ways that we can write ratios and proportions. Most of these you've probably seen before. So the most common way I think is as a fraction. So we could write it as A to B, and we can write it with a colon, and we would say it the same way, A to B. Or we can write it out in words, and we can write A to B. Again, this will be the most common way, and then with a colon, that'll be the second most common way. So when we're writing proportions, proportions are just a comparison of two ratios. I could write it with an equal sign and fractions, so I could write A to B is equal to C to D, or sometimes you may see it with colons. So A to B is equal to C to D. And if you don't like it in this form and it's given in that form, go ahead and convert it over to the other form with fractions. So when we have a proportion, each number is called a term. We have a term. Alright, so here's our proportion written in both different ways, and we can refer to each term as the first, second, third, or fourth. So we can see that A is the first, and then we're going down, and then over to the next ratio, and then down again. So A is the first, B is the second, C is the third, D is the fourth. And then some very, very important terminology. You have to understand the meaning of these words. If you don't, you're not going to be able to answer many of the questions, and you're going to be confused throughout the chapter. When we talk about the means are really the middle terms. Middle terms. Okay, and when we write this as a proportion with colons, it's easy to see that B and C are in the middle. Those are the means. The second and the third terms are the means. So these are our means. And then the extremes, those are the ones on the outside. So I've got A and D. These are on the outside. These are the extremes. Figure out how to spell here. Extremes. Okay, so again, when it's written in fraction form, which it'll normally be written, make sure you understand where the means and the extremes are. Very, very important. So getting to our first theorem of the chapter, the means, extremes, products theorem. So really, this is just a fancy way of saying something that you already know. In a proportion, the product of the means equals the product of the extremes. And so basically what this is saying, if we use our proportion above, the product of the means is B times C, and the product of the extremes is A times D. So really you probably just know this as cross multiplying. Okay, and we will use this a little bit in proofs. So keep that in mind if you want to add it to your theorem sheets. So that's the means extremes products theorem. This tells us what we end up with. We end up with products. We end up with multiplying. The means extremes ratio theorem says that we're going to end up with ratios. So the theorem tells you what your end product is. I think that'll help you keep these two theorems separated. And when we do have to use these in proofs, you can use the name of the theorem. So you can write means extremes products theorem, and you can write means extremes ratio theorem, but you need to know which one to apply. So for this one, it says if the product of a pair of non-zero numbers is equal to the product of another pair of non-zero numbers, then one pair can be made the means in a proportion and the other pair the extremes. So we're kind of going backwards from cross multiplying. So let's say we've got the following equation. We've got, and actually here's a typo here. We should have 5x is equal to CD. So we've got the following equation, 5x equals CD, and we want to write it as a proportion in three different ways using our means extremes ratio theorem. So we're going to have 3 different proportions. We probably could do this in a few other ways, or at least one other way. So what we're going to do is we're going to take one pair of non-zero numbers, so let's say the 5 and the x, and we're going to make them either the means or the extremes. It doesn't really matter, so I'm going to let them be the extremes over here. So I'm going to make that be 5 and x, and I'm going to take the other product, CD, and I'm going to let that be the means. So now I've got C times D. So I took one pair of products and it was the extremes. I took the other pair and made it the extremes. And so we can take these products and put them basically anywhere we want as long as they're across diagonally from each other in the proportion. So let's try another one. I'm going to take my 5 and my x and put them here. I could have these switched. It really doesn't matter. And I'm going to put my D over here and my C over here. So if you want to check to make sure that it works, just cross multiply it back out and make sure that you end up with the original equation. Let's do one more. Let's put C over here and D over here, and then x over here and 5 over here. Feel free to try one more if you like. Figure out, see if you can find one more ratio or proportion that you can write. All right, moving on. Arithmetic mean. The sum of a set of numbers divided by the number of numbers in the set. You guys probably know this better as an average. So this is an arithmetic mean. We also have what's called a geometric mean. A geometric mean is a proportion in which the means are the same. So when we talk about the means, we're talking about the second and third terms. Okay, this means that the second and third terms in the proportion are equal. They are exactly the same. And we're going to have a couple different names for this. Another name for a geometric mean is a mean proportional, and I will use these interchangeably. So you need to understand geometric mean is the same as mean proportional, and if I ask you a question, I'm going to use the terminology, both terminologies you need to understand. All right, so quick example here. Find the geometric mean between 5 and 15. So if it's a geometric mean, or a mean proportional, I know that the means are going to be the same. I don't know what they are, but I know they're going to be same, so I'm going to let them both be x. And I know it's going to be between 5 and 15. And then all I need to do is solve this by cross multiplying, so our means extremes products theorem. So x times x is x squared. 5 times 15 is 75. I'm going to take the square root of both sides. Make sure you have plus or minus square root of 75. So that's going to be, we need to simplify plus or minus the square root of 25 times the square root of 3, and the square root of 25 is 5. So plus or minus 5 root 3. If you're a little rusty on simplifying radicals, make sure you get some help in class while you're going through the problem sets. Okay, next example, 8 is the mean proportional between 4 and what number? So I know 8 is the mean proportional, so I know that 8 has to go in the means, and it's going to be between 4 and some other number that we don't know. Again, cross multiply means extremes products theorem because we're ending up with products. So 4x is equal to 64, which means that x is equal to 16. Alright, as usual, if you have questions, there's plenty of room in the margins to write your questions and ask me when you see me in class. Alright, so next example, we want to find each ratio. We want to find the ratio of x to y given 5x is equal to 8y. So we're going to use our means extremes ratio theorem because we're going to end up with ratios. So I'm going to take one pair and let them be the means, and one pair and let them be the extremes, but I know I want the ratio of x to y. So I'm going to start with the ratio of x to y. So I know the x over here goes with the 5. So if I have the x here, I've got to put the 5 here. And I know that the 8 goes with the y, so if I put the y here, the 8 has to go diagonally across from it in the proportion. And there's my answer. The ratio of x to y is equal to 8 to 5. So if you know what ratio you want to end up with, go ahead and start with that at the beginning. for example, with part B, we want to find the ratio of y to x. So I'm going to put y to x because that's what I want to end up with. And I know that my x goes with the 6, so my 6 has to go over here so that if I cross multiply it again, I'd get 6x. And my 14 has to go with the y, so I know that the 14 has to go diagonally across from there. And we're going to simplify this. Always simplify your ratio. So I'm going to divide by 2 to get 3/7. So my ratio of y to x is 3/7. Make sure you read the questions carefully to know if I want the ratio of x to y or y to x. All right. Again, I just want to repeat, if you have any questions, make sure you write those down and ask me in class. And we'll see you next time.